let's talk about normal distribution. So remember that for a normal distribution, the graph is a bell-shaped graph. So if you have x-axis, all of your x values are on the horizontal line, then this is the behavior of your graph. Remember that these are all small bars. These are all frequency bars. And since they're very close to each other, because you have a continuous random variable, you cannot distinguish between these small bars. And when you connect the top of the bars, the graph is bell-shaped graph. So x is continuous random variable. For example, x can be IQ scores. Well, when you have IQ scores as a normal distribution, the mean is going to be located here, the balancing point or the mean. So this is your mean or balancing point. But in many cases, we are not allowed to use x values. We have to convert x values into z values, z scores. To convert x values into z, we're going to follow formula z equals to x minus the mean divided by the standard deviation. This machine helps us to convert x values and find z values. So the graph of a normal distribution is going to be converted into standard normal distribution. This is the name for this new graph. This is going to be called standard normal distribution. So the behavior is going to be the same, but on the horizontal line, instead of having x, we're going to now have z. Just know the difference. X values on the horizontal line now, they are all converted into z values. Yeah, you're going to have the exact same graph. The behavior is going to be exactly the same. There's no difference. But the mean is going to be 0. The standard deviation is definitely 1. So these are all small bars. They are connected together. We cannot distinguish these bars. Why is that? Because x was a continuous random variable, and as for z. But the name of this guy, since we change x values into z values, is called standard normal distribution. The mean is going to be 0. The balancing point is 0, and the standard deviation is 1. Very good. So the area below these two graphs is exactly 100% or 1. So if somebody asks you, hey, what is the area? What is the probability below the graph? You're going to say, hey, it is 100% or 1. 100% or 1. Very good. So we're going to use this information and find the probability for a continuous random variable.